Yeah, find my pen. Okay, so rational exponents, meaning we're going to have a fraction as our exponent. Okay, we're going to have a fraction as our exponent. So just as a reminder, what kind of happens when you have b raised to the 1/2 and you square that? Okay, if you have two exponents together here, you can multiply those. Okay, so those are multiplied together. That's where you multiply those exponents. So I would end up with b to the 2/2, okay, which is just b to the 1st, or b. Okay, so you multiply those together. So if you have, say, b to the 1/3, and you were to cube that, that's how you would get it to b to the 1st. Okay, because you know you can multiply those together. Okay, so b to the 1/2 power is a number with a square equal to b. So b raised to the 1/2 power is just the square root of b. Okay, so that's what those fractional exponents are. They're roots. Okay, so b to the 1/2 is just the same as the square root of b. So b to the 1/3 would be the cube root of b. So whatever number's in the denominator of that fractional exponent, that's the root. So for b to the 1/n, for any real number b and any positive integer n, b raised to the 1/n power is equal to the nth root of b, except when b is less than 0 and n is even. When b is less than 0 and n is even, a complex root may exist. Okay, meaning you have the negative number in your root. Okay, you get imaginary numbers. So example, if I have 27 to the 1/3 power, that's the same as the cube root of 27, which is just 3. If I have negative 16 to the 1/2 power, that's where they're talking about if you have a negative in your root and it's even, an even root, you end up with 4i. You end up with imaginary numbers there. Okay, so rational exponents. For any real non-zero number b and any integers x and y with y greater than 1 and b raised to the x over y power, your y value, so whatever's in the denominator, is your root. Whatever's in the numerator, okay, that's the power attached to attached to your number or radicand inside your root. Okay, so we can highlight those different colors just to make it look a little bit nicer here. So if you have this x value that's inside your root, I know it's hard to see. If you have that denominator y value, that's the root itself. Okay, just so you know where each of those go. Okay, you could also write it as the y root of b raised to that power. Okay, so it's just raised to that power from that numerator. Okay, except for when b is less than 0 and y is even. Again, you get that complex root if you have that negative inside your radical. So an example, we have 27 raised to the 2/3 power. So we have the cube root, taken from the denominator of 27, and that's squared. Okay, so the cube root of 27 is just 3. I still have that number squared to get 9. If I have negative 16 to the 3/2 power, okay, negative 16, this is a square root because of our 2 in our denominator right here, and then that's cubed. So you have 4i cubed, or negative 64i. So we're just going to practice simplifying each of these. So we're going to switch it from radical form to rational exponents. So for letter A, we want to write a to the 1/5 power in radical form. Okay, so if it's 1/5, that 5 in the denominator becomes your root. So I know this is the 5th root of a, and then my numerator is just 1, so I can just leave it like that. Okay, so we're just switching from rational exponents to radical form. So that would be my answer for that one. Okay, then letter B. This time I want to put this in exponential form. So if I have the 8th root of c, that becomes c to the 1/8 power. Okay, my c has a 1 attached to it, so that goes in the numerator. My root goes in the denominator. Questions? No, we're good so far? So letter C then, we want to write d to the 7/4 in radical form. Okay, so here I would have a 4th root, because that's what's in the denominator, of d, and then that quantity is to the 7th power. Or you could have the 4th root of d to the 7th and write that 7 inside your radical as well. Okay, here we want to write the cube root of c to the -5th in exponential form. Okay, so we have c as our base. Our root is 3, that goes in the denominator. Our numerator number then is this -5. So we would have c to the -5/3 power. Okay, so just switching back and forth between the two. Okay, questions on those? All right. Then in example 2, we want to evaluate the expression. Yep. Right on there. You slipped it. All right, so we have letter A. We have a -3,125 raised to the -1/5 power. So I'm going to rewrite this because I have this -1/5 power. Do you remember if you have a negative power, what happens to it? If I have a negative power, what happens? Or exponent, negative exponent, what happens? No? You take the reciprocal. It flips it to the denominator. So here I could rewrite this as 1 over -3,125 to the 1/5. Okay, that way it gets rid of that negative exponent there. So then I would just want to take that -3,125. I want to take the 5th root of that. So either way on your calculator, so here we go. I can either do this one where I have 1 divided by, we need the 5th root, so I would press 5, and then 2nd, and then the root with the x on it, okay, to take the 5th root of -3,125. Okay. Or if that's too difficult, we can use our fraction exponent here. So if I wanted to take -3,125, I could raise it using the caret key. Okay, so raise it to a power of 1 over 5. So raise it to that fraction. So that caret and then the fraction 1/5. Okay. Does that make sense? And I just did this bottom one. So I'll get either -1/5, which is also -0.2. So either way you enter it into your calculator, you'll get that same answer. So we're going to do the same thing for letter B. Now this one, I would just keep it as it is. Okay, so practice entering that into your calculator if you have one. I would type in 256. I'm going to raise it, so use the caret key. I'm going to put parentheses, and then I want to write out that fraction of 3/8. Okay, so 3 over 8, because I'm raising it to that power. You with me? Yes? To get my answer of 8. Okay, so you can just enter those into your calculator to see what that answer is. Questions so far? Changing from radical to rational exponents or evaluating your rational exponents on a calculator? If you need to borrow a calculator, you need to let me know. All right, then, moving on here. So all the properties of powers you learned before apply to rational exponents. So we want to write each expression with all positive exponents. Okay, you can't have negative exponents. Also, any negative or any exponents in the denominator of a fraction must be positive integers. So if you have your fractional exponent and that number is in the denominator, you need to simplify it. Okay, you can't have a negative exponent and you can't have a fractional exponent in the denominator. So it may be necessary to rationalize that denominator. So in example 3, we're just going to simplify each of these expressions. So if I have p to the 1/4 power times p to the 9/4 power, okay, I can add these two together. When you add fractional exponents together, you need to make sure you have a common denominator. These two already have a common denominator. Okay, they're both 4. So I can write this as p to the 1/4 plus 9/4. Okay, I can add those two together to get p to the 10/4 power. And I can simplify that fraction. Okay, 10 and 4 both divide by 2. So dividing by 2, I would get 5/2. Okay, so that's simplified for letter A. Letter B then, I have r to the negative 4/5 power. Again, I don't want a negative as part of my exponent. That negative actually reciprocates it, so it flips it to the denominator. So I actually end up with 1 over r to the 4/5 power. Now, I don't want a fraction in the denominator. Okay, I don't want a fraction in the denominator. So I need to multiply by a version of 1, where when I add my two fractions together, I get 5 over 5. So I'm going to multiply by r to the 1/5 in the numerator and denominator. Okay, that way when I add together my two fractions, I get 5/5. So here I would end up with r to the 1/5 over r to the 5/5. Okay, that's exactly what we did when we had different roots before. When we had 1 over r to the 5th root. Okay, we had to multiply by a version of 1 to get that root out. This is a little bit easier because you can think about it as fractions and adding them together to get a 1. Okay, so here I would just end up with r to the 1/5 over r. Okay, questions on that? All right, we have a couple more here that we're going to simplify. So when simplifying a radical expression, always use the least index possible. Using rational exponents makes this process easier, but the answer should be written in radical form. Okay, so if I'm starting with radical form here, I want to end with radical form. Now this kind of looks similar to what we were doing before, right? But I can now change this to rational exponents and it makes it a little bit easier. So I can write this fourth root of 32 as 32 to the 1/4 power. Same thing with this 2 in the denominator. I have the cube root of 2. I can write it as 2 to the 1/3 power. Now, when we're combining exponents, you need a common base. Okay, so 2 and 32 are not common bases, correct? But I can change 32 to a 2. Okay, I can change 32 to a 2. So I can take 2 and raise it to the 5th power to make 32. Okay, so I just changed this number here to 2 to the 5th because I wanted it to be the same as this base of 2 in the denominator. Okay, you want your bases there the same. Does that make sense? Yes? So I had to change it somehow to make those the same. So now in the numerator here, I would end up with 2 to the 5/4 power over 2 to the 1/3 power. Now, when you have this quotient here, which is that fraction, and you have common bases, you can subtract your exponents. Okay, that's a rule of exponents, right? So I can take my common base of 2. I have 5/4 minus 1/3. Now remember I said you need a common denominator to subtract or add fractions. Okay, so what would my common denominator be between 4 and 3? 12. Okay, so I would have 2 to the 15/12. Okay, because I had to multiply both of those by 3. Here I have to multiply both by 4, so minus 4/12. To end up with 2 raised to the 11/12. And they did say that it has to be written in radical form at the end. So now I want to just change it back to radical form. Okay, so that 12 on the denominator is your root. So this is the 12th root of 2 to the 11th power. And that would be my answer. Okay, so you can kind of see how it's a little bit easier to rationalize that denominator when you have those fractional exponents. Okay, a little bit easier to rationalize that denominator. Okay, questions on how I did letter A? Did you follow each step? All right, then we're going to go to letter B. So, again, I'm just going to change this into a fractional exponent. So this 4, I'm taking the 6th root of. So I would change that to 4 to the 1/6 power. Okay, I'm taking the 6th root of that 4. This x to the 4th then, I would have x to the 4th 6th power, because it has that exponent already. Okay, so that would go in your numerator, and then that 6th power there would go in the denominator, because that's your root. Okay, I can simplify this 4/6, right? I can simplify that fraction. So I have 4 to the 1/6 power and x to the 2/3 power. Okay, I just simplified 4/6 to 2/3. Gotta remember where I was going with this. So here, this 4 Okay, I can change that to a 2. Okay, I can change 4 to a 2. And that would be 2 squared. Again, so I have the same type of power going on here in the denominator. So if I were to multiply these two together, I would have 2 over 6. So I have 2 to the 2 over 6 power and x to the 2/3 power. And again, I can simplify this fraction then. So we have 2 to the 1/3 power and x to the 2/3 power. Okay, I did that so that both of those were in a cube root instead of a 6th root. Okay, so I simplified from a 6th root to a cube root now to keep that same number. So just rewriting this as a radical, we have the cube root instead of the 6th root now of 2, and that would be x squared. Okay, so I simplified from the 6th root to a cube root, that 4 to a 2, and that x to the 4th to an x squared. All right, then last one here. So in letter C, we do have to use a conjugate, which is what we talked about on Thursday. Okay, you have to use that conjugate and multiply your numerator and denominator by it. And I have to do that because I have this fraction in my denominator. Okay, I don't want the fraction in the denominator, just like I didn't want the root in the denominator. Okay, so your conjugate has to do with your denominator, but you need to switch the sign. Okay, so instead of subtraction, I would write this as y to the 1/2 plus 2. Y to the 1/2 plus 2. Okay, so that's your conjugate. Then we just have to FOIL the numerator, FOIL the denominator. So multiply your first two terms together. So y to the 1/2 times y to the 1/2 is just y to the 2/2. Okay, you add your exponents. Okay, multiply my outer. Okay, so that would be 2y to the 1/2. Multiply your inner, so 2y to the 1/2. And then multiply your lasts. So 2 times 2 is 4. Okay, same thing in the denominator here. FOIL, so multiply the first two, so you have y to the 1/2 times y to the 1/2. That is y to the 2/2. Your outer terms, so 2 and y to the 1/2, so plus 2y to the 1/2. Your inner terms, so I have this minus 2 times y to the 1/2. So we have minus 2y to the 1/2 power. And then multiplying your last terms, negative 2 times 2 will be negative 4. Okay, and from here I can combine like terms, simplify a little bit. So y to the 2/2 is just y, right? I have 2y to the 1/2 plus 2y to the 1/2. Those are like terms. I can combine them to get 4y to the 1/2. And then I have plus 4. My middle two terms in the denominator here cancel each other out. So I just have y minus 4. Okay. If you were to rewrite this in radical form, okay, like it's set up here, I would end up with y plus 4 times the square root of y plus 4 all over y minus 4. Okay, so that's just rationalizing the denominator again. So you're multiplying by that conjugate. Okay, so you do need to know how to switch between rational exponents, so those fractional exponents, and a radical. Okay, you need to know how to simplify using rational exponents. I think simplifying using rational exponents is way easier than with a radical. Okay, because then you can just see what you have to add to your fraction to make it 1. Okay, instead of trying to multiply by another radical with a power to it and stuff like that. The first couple problems here, 1 through 6, you're just rewriting that either as a radical or a rational exponent. You're not simplifying anything like that. And then 7 to 10, you're just evaluating, so using a calculator. And then the ones on the back are the ones you're simplifying.